Okay, now that we've talked about how the surface of our Earth can be changed by destructive and constructive forces, we're going to switch and talk about one of the main forces that causes those changes to the Earth's surface, which is water. So our essential question today is, how are various properties and uses of water related? This is Learning Target 7, describe and identify the properties of water and how our water sources are being used. Okay, so the first section of our notes, we're going to talk about the physical properties of water. Okay, just so you know, the chemical formula for water is H2O. What that means is that this 2 goes with the H. H stands for hydrogen. So 2 hydrogen atoms are bonded with 1 oxygen atom. Okay, so let's take a look at water's physical properties. Water can exist in 3 states of matter. Water can be a solid, liquid, or a gas. Remember, all matter has mass, so water does have mass. It's the amount of matter, okay? Water has volume, which means it takes up space. So you can see the rest of that, okay? And water also has density. Density is how heavy something is. So if you take a look at this picture, mass is the amount of matter. Okay, so those little circles represent what we call atoms, and when we get into our chemistry unit, you'll understand a little bit better about what atoms are. They're also called particles. So whatever makes up matter, all that matter is the mass. Volume is how much space that matter takes up. Density is how heavy that matter is. So when we look at density, we look at density as a relationship between mass and volume. Now, for water, water has a density of 1. And because because density is a relationship between mass and volume, mass is measured in grams, volume for our sake is usually measured in milliliters, so that's why it's 1 grams per milliliter. If something sinks in water, then you know its density has to be greater than the density of water because it's sinking. So that would mean that if something sinks in water, its density is greater than 1 because water has a density of 1. If something floats in water, then that means that the density has to be less than 1. It has to be lighter than water. Okay? So when you throw a rock in water and it sinks, you know that rock is denser than water. When there's an oil spill, oil is less dense than water, so it's lighter. That's why it floats on top. Now, one kind of unique property about water is that the solid water is less dense than liquid water. That's why when you pour a glass of water with ice cubes, the ice cubes float to the top. That's also why the lake freezes on the top. And this is pretty important. Life would not be able to exist in water if this did not happen. Because if the solid water was more dense than liquid water, then that would mean that the lake would freeze from bottom up and no living thing could survive. So the fact that solid water is less dense than liquid water allows for life to occur. So a lake freezes on the top, animals and plants can still survive below the ice. So that's a very unique property to water. Most other substances that we have the opposite. The solid will sink in the liquid. But water's pretty unique that way. Okay, so sources of water here on Earth. About 97% of our water is salt water in the ocean. Only about 3% of the water is fresh water, and we find that in our lakes, our ponds, rivers, groundwater, and glaciers. So let's take a look at how water is used and distributed in the U.S. Did I miss? Hold on just a sec. Sorry, guys. Nope, I didn't. Okay, so uses. We use water for irrigation. That means watering our crops to grow food. About 31% of all the fresh water that we have is used for irrigation. 11% of it is public use. That's our drinking, cooking, bathing, washing clothes, going to the toilet. That's all 11% of what we use that fresh water for. 9% is used industrially when we use water treatment and cleaning. And then hydroelectric power, which is pretty cool, is an energy source. That's using water as an energy source, is 49%. So let's take a look at how water is used globally, people and the planet. Okay, 70% of the water for human use is soaked up by agriculture in the form of irrigation. 23% accounts for industry, and then domestic use is about 7%. So across the world, irrigation for crops is where most of our water is going to. Okay, use of fresh water in the United States, again, 41% is agriculture, 38% is industry with a little bit more with the power plant. That was the hydro electric power. 11% industry, 10% public. In China, take a look at that. 87% is just agriculture, 7% industry, 6% public. So that kind of gives you an idea of how our fresh water is used in the United States and how that's pretty different in other countries. Okay, let's go back down here and look at the hydroelectric power. Okay, so an average person in the U.S. uses between 65 and 80 gallons of water per day for drinking, cooking, bathing, and watering their yard. The average person in the Netherlands, which is like where Amsterdam and Holland is 27 gallons per day. So we use a lot more water than most other countries per person. Okay, and distribution. So how is water distributed in the U.S.? How do we get our water? Most of it is through pipes, valves, and holding tanks and pumps. So, and you've probably seen this in your own house. You have water pipes that go to your house. And then we have big holding tanks that hold water. I know in Idaho Springs, one of my issues is the house that I live in. We are just a little bit below the holding tank that holds their water, so my water pressure isn't as good as someone who's a little bit lower in elevation. They actually need to raise that holding tank. But that's how water is distributed in the U.S. We use pipes and holding tanks, and then we have pumps and valves that will determine how fast that water is getting pushed through the pipes. Okay, so hopefully after this you've got a better idea of what are some properties of water and how we use water in the U.S. and compare it to the world.